Hi, this is Pat Moorhead, and we are here for another 6.5 on the road, and we are talking about IBM's full stack infrastructure, but more importantly, the future of computing. And we've spent the last couple days going in between Yorktown, New York, and Albany, New York, talking to many of IBM's brightest folks at their research facilities.
Yeah, there's a lot of very, very smart people that we've had the chance to sit down with, Pat. And for us as industry analysts, we're really trying to inform ourselves, so then therefore we can translate that knowledge out to all of you and to the market, because the nature of computing is shifting so much, and we're seeing how workloads are being distributed. We're seeing the impact that semiconductors are playing on the world. We're seeing new technologies like quantum rise, and people are kind of wondering, well, how does this contribute to what the future is going to be? And of course, data proliferating and exponentially growing. And IBM, interestingly, has a really full stack story that I think needs to be told more, and so many people out there could benefit from hearing. So that's what we did. We went on the road, and you'll see us sitting here, you'll see us sitting in a few other spots, but really we're going to talk to some great people, and it's going to be a great conversation if you can just give us a little bit of time.
Yeah, I'm super excited about this, and part of industry analyst role is to educate, and this is what this is about today. And I found it super special because it combined not only deep chip tech, but also all the way down to the practical level of delivering cloud services to clients.
And without further ado, we're going to go to Dr. Khare, and we're going to talk about semiconductor research, hybrid cloud, and so much more. So join us. Mukesh, it is so great to have you here. We're here in Albany at the Nanotech Center, having this conversation about the full stack future of compute. And boy, what a great opportunity to have you join us on the 6.5.
Thank you. It's my honor to share what we do here in Albany Nanotech.
There's so much history with IBM and chips. You were doing your own first-party silicon for systems before it was cool, right? We talk about heterogeneous computing. You'd be doing a lot of that with ASICs, fixed function, accelerators. It is super exciting. And at one point, you were a major manufacturer. In fact, I worked for a systems provider in the 90s that bought chips from IBM Broad-Scale Foundry, which I know that strategy has changed, but here we are. It's an exciting week here with the CHIPS Act and everything. But can you talk about your vision and your strategy moving forward? And before I forget, I want to point out the incredible amount of IP that you provide, sometimes publicly, sometimes not, to some of the biggest chip producers and designers on the planet.
Thanks. Thank you very much for, again, this opportunity. IBM as a company, our strategy is very clear. We are very laser focused on our hybrid cloud and AI strategy, right? And as you said, from the beginning, IBM has been working on the full stack approach. I call IBM stack the golden stack. It's a golden stack which includes everything. We have infrastructure business, we have our software business, which includes Red Hat, which is a hybrid cloud platform, and then we have consulting business to help client grow through the journey. So those are the three ingredients for IT industry. And today we are here at the infrastructure part of our stack that we're going to talk about. And clearly, semiconductor, as you know, semiconductor industry started in the US, and IBM was the company who created these scaling laws, the laws that Bob Dennard created, which essentially defined how do you scale transistor, generation over generation. However, over a period of time, IBM's strategy has evolved as the industry evolved, right? Our view is very simple. We want to focus on things which we are good at, which we can do, and we want to partner with companies with the value that they bring to the table. So today, what we focus on is the research and development part, because that's our strength, that's in our DNA. So we drive research and development agenda, a very strong R&D agenda for IBM's business, and we partner with companies who bring in manufacturing scales or who need certain IP for their business. so that it's kind of a complementary relationship. And that's our new model where we are focusing on developing technology for our product as well as helping our partners to build their product for their business. So that's the new model that we are on right now.
Yeah, it's really interesting. You mentioned, did you call it the golden stack? Is
Yes.
that what you called it?
Yeah.
All right, I'm gonna hold on to that one. I'm watching that. But it is really fascinating, just having spent some time here, seeing kind of how the research informs everything else. And you've got a really big role in research. And so we've sat down actually on the 6.5, Arvind Krishna, your CEO, joined us. And he also illuminated us on the visions for hybrid cloud and AI. And that's something it seems you're very focused on.
That's right.
How does that sort of continuum function from research to the development of and execution
Yes.
of what's now your hybrid and AI strategy, which we're very clear, those are the areas that you talk about accelerating at, and that's where right now IBM is accelerating.
That's yes, spot on. So with the stack that we work on, we work with clients, we understand the client's needs, and then that gives us feedback into, okay, what type of system technology, what type of chip technology, what type of process technology we need to develop to solve client problem. A great example of that is our Z16 recent announcement where we introduced an AI accelerator inside our Telum processor, because we understood that there is a very strong need of during transaction AI inferencing. So we were able to translate that into what does it mean at the cloud level, what does it mean from a chip design level, and at the process technology level. And here in Albany Nanotech, we had launched an initiative called AI Hardware Research Center, and we used a partnership model to develop the core, the inferencing core that then goes into our own chip that then solves our client's problem. So the fact that we worked on the entire stack, we come from what does client want, and then we fortunately at IBM can go at the lowest possible level, at the process level, at the chip level, to solve client problem in the best possible way.
So one of the things I appreciate about the folks that are doing research, and by the way, I like to separate research from development. There's a lot of people who do development. There's not a lot of people who do research, but a lot of things that I think about is our business models. Because at the end of the day, doing research and development for the sake of research and development doesn't make the shareholders happy, and it doesn't.
You're a university.
Yeah, exactly.
That's right.
So what is the IBM business model? You're in so many different places, and I don't hear a lot about it publicly, but I do ask you. Can you talk a little bit about that?
Yeah. No, that's so first, to answer first part of your question, we do R&D not for the sake of R&D. We are a business, and anything that we do here in Albany Nanotech or in IBM Research is to have an impact to a product, impact to an IBM product, as well as impact to our partner's product. So that's the first part. It's a research which will have an impact to a business objective at the end. So that's the way we think, and that's why IBM Research is one of the, I guess, only and extremely successful research organization in the world. The second part I will say is that yes, the model for research, and we at IBM essentially invented a new model for research and development. We started the model of partnership where companies with a shared need co-invest. And we started this partnership model more than 30 years ago, actually, with IBM's DRAM Alliance, then transitioned into Logic Alliance, and here we are, which is world's in Albany Nanotech, which is the world's most advanced public-private partnership, where we are collaborating and co-investing, which is very important because co-investment not in terms of dollars, but also in terms of intellectual capital, right? Because we bring intellectual capital from IBM, our smart researchers from IBM, as well as other companies who are partnering with us. They bring their best people, best talent, their best equipment, and best investment, so that it's a very unique model where we are co-creating at the end for the benefit of our business. So that's the unique model. We do generate a significant amount of intellectual property, IP, that definitely helps us, make sure that we have, we will have technology from an IBM lens. We will always have knowledge, IP, and technology that we need for our business. And obviously that can also help us to, monetize that IP through licensing or through other models as well.
Yeah, the opportunity for that IP to translate to revenue is tremendous. And we of course know that there's so many products that have hit the market and developed that IBM had a part to play in.
That's correct.
And in many of them, the average consumer may not know that because where it got licensed or sold off or abandoned. I mean, there's the history of research. You just got to go to any of these facilities. You and I've had the fortune of going to headquarters and being in some of these and just seeing things and going, oh wow, did not know IBM did that. And so it's really, really interesting. And one of the areas that is very interesting is some of the IP leadership in semiconductors. I believe it was maybe earlier this year, last year, I get the dates right, but you announced 2 nanometer. And of course, that's at the very leading edge of the leading edge. Talk a little bit about that type of innovation, where that's going next, and how, kind of how being on the front end is a big part of your strategy.
That's a great question. And yes, our goal is to be, develop technology which is absolutely leadership technology, because that's what IBM business wants, right? You will speak with Ross Mauri, who is the general manager of IBM Z business. Product or technology requirement for IBM systems business, Z business, and power business is like the ultimate standard. If you can meet the requirement for that, you can meet requirement for everything else that is out there. So clearly, to us, leadership is very important for research division and for me as a research leader responsible for hybrid cloud technologies. Now that said, we have been driving this, especially in the Albany Nanotech Center. In 2015, we announced 7 nanometer technology, which was world's first announcement of such chip technology using EUV lithography. That got adopted by all the major players. Then we were the first one to announce gate-all-around nanosheet technology. And that's very interesting because the idea of gate-all-around was always there. But how do you make it real for product? That was not known. And that's where we, from our product lens, brought in the sheet idea. And that nanosheet idea is the idea we believe is going to be adopted by most of the companies have already announced. That will be the structure going forward after FinFET. And then, yes, last year in 2021, actually, we announced 2 nanometer technology, which is the second generation of nanosheet technology. We are working on that technology here right now in Albany Nanotech with many partners. We are co-creating, perfecting that technology because we really want to make sure that both the technology is manufacturable so that our manufacturing partners can take it for volume production. And at the end, technology has features that IBM needs for our own product. Ross needs for his Z product, as an example. We need for our cloud product. So we want to make sure both of those needs are covered as we continue to make progress. On this site, we are working on technologies beyond 2 nanometer now. You will see more and more come out over a period of time as we perfect that technology with our partners in all of these cases. What's beyond nanosheet, it's coming in the pipeline. And another technology that we are very excited about is the Chiplet Technology. And that's going to be another future which will supercharge Moore's Law, in my view, beyond the traditional logic scaling. And in fact, during the pandemic, we invested together with New York State to build a fab here for chiplet innovation, and that's coming online. And you will see more and more of such technology essentially at the forefront coming out of this lab.
Mukesh, I would love to sit here for hours and talk with you about this, but listen, this is the first stop on talking about IBM's full stack approach and also on the future of computing. So this is our first stop, and I appreciate us kicking it off with you. And we're going to talk to Ross. We're going to talk to a lot of different people about this down the line. But thank you so much for your time. And being on the 6.5 for the first time. I appreciate that.
Thank you. Thanks for the opportunity. Thanks for this great conversation. And we can't wait to share with you all the exciting things that we do at IBM Research.
That's great. And if you want to tell us early, you can too.
Thank you. We will do that.
Take care. It was great touching base with Mukesh. I'd only done Zoom with him before, but actually meeting him face to face was great. And I always learn something when I talk to him. Right? We talk about what we do here at the facility in Albany, and it's transistor, it's manufacturing, it's AI, but it's also packaging, and that's something I need to learn a little bit more about what they do here.
Yeah, I like the way he was able to tie together how research really connects to what Arvind has been talking about so passionately, and that's the hybrid cloud and AI opportunities. And we're starting to really see, as a result, that this is becoming much more crystallized in the interactions that we're having with the executives at IBM. And if that's going to stick, if it's going to stick in the market, it has to be the first thing on the tip of the tongue of all the executives. And that's kind of what I'm sensing from these trips, from these tours, and of course these executive conversations.
Yeah, I like the business model reaffirmation too, because IBM can't talk about all its customers and exactly who they do it with and who they do it for, but it was good affirmation to know, well, first of all, make chips for Z and Power, right? And not just the general purpose parts, but also the ASICs, the accelerators. He talked about the block that he puts in Telum for AI, but also the intellectual property that goes along with that. And I don't think there's a company out there, a designer, and even a manufacturer with big names who IBM isn't touching. They don't talk about all of them, but that's okay. I appreciate that anyways.
Well, not everyone wants credit for everything, and that's all right.
And next up, we're going to be talking to Ross Mauri, who runs the Z division. He's going to be talking holistically about systems, and it's a great segue coming from Mukesh. You talked about semiconductors and what the company is doing in that area.
Always great to talk to Ross and connect the dots.
Ross, it's great to see you again. I think we bumped into each other at one of the first IBM Thinks that was back in person again. I love that venue, by the way. But we're here in Albany right now, we're on kind of this IBM road tour, talking about the future of computing and really getting underneath of what IBM is doing, looking at your top to bottom approach, and here we are. So it's great to see you.
Thanks, Pat. It's great to see you too, and I love being here in Albany. This is the researchers and scientists here really make a difference for the future of my platform, the Z platform, and so it's great to be in this setting and to see both of you here today.
Yeah, the road to Albany is beautiful. It's very green, very lush. If you haven't been here, I think people should probably visit sometime. But yeah, we've had a chance to speak to you and a number of your colleagues, and we're really kind of looking at this future of compute narrative and this full stack story. And IBM has such an interesting, compelling story. There's so much history, and then obviously so much innovation going on. And I want to start there with you, Ross. We just got finished. We talked to Mukesh, looking at the whole kind of semiconductor research part of the business, where that's heading, and of course you leading a big part of the systems business in IBM Z. I want to kind of talk about what we talked with Mukesh about with the semiconductor and the research, and how that really informs and drives the business in systems for you.
So we've had a very long, decades-long partnership with IBM Research. And yes, it is around the silicon, it is around the chips, it is around fundamental computing paradigms. And research is really, I would say they're an essential part of the Z business. And one of the things, I know that heterogeneous computing and full stack integration is coming into vogue now, but that's something, the mainframe platform has basically taken advantage of for decades. And it does start at the silicon, because the fundamental performance, reliability, and security of the system is baked in from the chip, the packaging, to the central electronics complex, and including the memory, operating system, right? I can stack it up, right? But again, research is fundamental to most layers of the Z system. And again, back to semiconductors. What research has been able to push for us, not only in terms of density and speed of circuitry and things that allow you to pack more horsepower and more capabilities into a smaller area, but also some fundamental breakthroughs like around security, like post-quantum crypto, right? And we've seen the recent NIST announcement. It was really thrilling that all 4 of the first accepted algorithms had IBM researchers participating in them, and 2 of them were led by IBM. But that type of partnership and leveraging of innovation is key to my business. And I love the fact that research is looking 5, 10, 15, 20 years down the pike. They're solving hard problems with us for our clients, even before our clients run into those problems, so to speak. So I think that's one of the great things. And again, to me, it really all starts at the semiconductor up.
Yeah, it's a great time right now. I mean, for I would say, if I could look back 20 years ago, people were talking about semiconductors being this commodity, right? And I've always been a big believer that people allow themselves to be commoditized. And here we are now where I think everybody knows what a semiconductor is. And I've always loved your fit-for-purpose approach that seems to be in vogue right now. So I don't know if you started the trend or you showed people how it could be done, but a lot of companies have jumped on the bandwagon, and here we are talking about this. One other thing that people might not know as well is that IBM Z and the mainframe is very much cloud-enabled. Your clients obviously know this, but a lot of people don't. So I'm curious though, how does Z fit into the overall IBM Cloud story?
So I think we fit very, very well, I'm happy to say. I mean, you can take cloud at different layers of the stack again. You could take it, I would say, at the highest layer where we have IBM mainframes and IBM Power Systems fully integrated into the virtual private layers of the IBM public cloud, so that you can access a mainframe capability, but through a PaaS service, right? Through a web service.
Right. In fact, you have a big-time security service.
That's right. That's right. In particular, what clients want is they want to keep their own crypto keys. They don't want anyone else touching them. And the mainframe has, I would say, the best cryptographic capability of any system in the world. And so by putting some mainframes in the IBM public cloud, all the services, whether they're not necessarily running on the mainframe, they might be running VMs on x86,
right,
but they're accessing those crypto services. So again, at the highest level, the mainframe integrates well with the cloud. But then there's all different layers that I would say that are just as important in a multi-cloud, hybrid cloud world. Connecting applications via a common platform like Red Hat OpenShift, right? And having containers be more of a fundamental way to develop applications, not just for portability, but I would say for better manageability, being more agile. And the mainframe integrates with every key Red Hat product into the OpenShift stack. And again, there's layer after layer, at middleware layer, at service layer, like a Kubernetes OpenShift layer, down deeper. We're integrated all the way. And IBM has 2 strategies really that we talk about at the highest level, hybrid cloud and AI. And we're integrating at all levels on both of those.
Okay, real quick, wait, are you telling me that the IBM systems they run Linux and they run containers, and you can address them in the public cloud, and they're part of a complete hybrid cloud architecture? I'm being a little snarky, of course, but it's like,
yes,
not
absolutely.
enough people know this, but I think it's a real testament to a lot of the success that you've been having over the past few years.
Thanks. And our clients have been telling me that they want us to better integrate. And again, with some common software platforms, that's been very easy. We always have to put a little bit of the mainframe into what we do if something does become distributed, like say the security model and things like that. Because again, our clients are especially the ones in regulated industries, are basically, they're counting on the highest level possible of security that our systems have for their applications and their data.
Something interesting that we had the chance to speak about in one of our briefings and interactions, Ross, was sort of how the chip technology has advanced so much, the design, the packaging, to be able to do more on chip. And in your newest Z16 iteration, this sort of ties into the whole hybrid story that we're trying to tell here, though. You brought AI much closer.
Right.
I just kind of, is that a great example in your mind, though, of sort of how the relationship with research and systems and how you develop products, is that maybe like a concrete example in this most recent generation of what's really happening in that relationship?
I think it's a fantastic example because research had been looking at AI and doing AI silicon for a number of years, and they were doing test beds and demonstrations, and we saw one of the engines that they had built, and it dawned on some of our lead technical folks about 6 years ago that what if we were to actually embed an inference engine, an inference accelerator right onto the microprocessor, kind of like on a different side of the bus than everybody else has AI implemented. What could we change? And so research worked with us, and it was actually their logic for the AI inference engine that we took, and then we adapted it and made it really robust and a lot of error checking and all that as you would expect in a mainframe, and integrated it onto the silicon. And so now we can do things that no other system can do. With guaranteed a millisecond or less latency, we can do 300 billion inferences a day on one system, on one mainframe system. So we're bringing high performance, low latency inferencing into the decision process of something like a transaction that a bank or a payment company might do. Game changing.
When we by the way, I guess the fancy word we use that for anything that's not, let's say, a general purpose CPU is heterogeneous computing. You talked about AI acceleration, but you do a lot more too, right? You have crypto, you have FPGAs. You were doing ASICs before it was cool, okay? Now it's cool too, but let's dial out a little bit. How is this changing the way that you're recommending your clients look at the overall estate of their enterprise architecture?
Well, it's in a number of ways, but I would say one that's really fundamental to what they do today is, as you know, they use the mainframe for a transactional engine, and the operational data that's created is really core business data that's relevant for many uses within a business after it's created. And so, the 2 decades ago, or maybe more, people started copying the data off the mainframe because they didn't think they could do things like advanced analytics or AI on a mainframe. So they'd copy it off. When you copy data, you open up a security risk because you now have multiple copies of usually highly valuable data. There's complexity, there's cost to it. And one of the things clients we're saying is we want to be able to use this data more real time.
Right.
So that means, as opposed to copying it off and processing, post-processing, let's do more real time. And that's what, again, the partnership with research, listening to clients, and then trying to bring the value of the integrated stack, back to the integrated stack, right to the middle of our clients' businesses. And we're doing that.
That's great.
Yeah, there's a lot of excitement here. Clearly, this most recent cycle has shown a lot of momentum. It's always very interesting, and Pat, I think you'd share my sentiment, to sort of hear how these different threads come together, how the research, you and I always talk about how we need more R and not just D,
Yeah.
And there's a lot of that going on here in Albany where we're talking, Ross, and of course it's always great to sit down with you. Thanks so much for your time.
Absolutely.
Yeah, I appreciate
Thanks,
it. This is, I think you did the 6.5 Summit 2 years, so
Yep.
you're not a newcomer, but here we are again, 6.5 on the road in Albany.
We'll be back.
Yep.
Thanks so much. Thank you.
It's always great to talk to Ross, and I'm just getting to know his team and the Power team. They were doing cool SoCs and application-specific integrated circuits and accelerators before it was cool, right? And I think they deserve a lot of credit for that. And it's not for just doing it. They actually get their clients get business value out of it.
Yeah, it's a lot of fun when we have the chance to talk to Ross about that too.
Yeah.
All that business value and some of those specific customer cases. Look forward to maybe someday sharing those a little bit more publicly. But when you sort of hear how the research turns into value,
Yes.
I think that's when I, as an analyst, get really excited because, sometimes you hear about a concept and a concept and a concept and you go, what's the intrinsic value? What's the market value? What's the consumption value?
Right.
And this is what we're starting to feel is that these investments in really what is a full stack future of computing architecture are starting to come to fruition.
No, it is good. I mean, you got research to the development, to the product platform, to clients and delivering value. You don't see that in too many companies, but it is good to see. There's not enough of it out there, but I always love talking to Ross. So who do we have up next, Daniel? What are we talking about next?
Yeah, so we have Hillery Hunter joining us. We're going to be talking about IBM Cloud, and we're going to be making the connections. Started at the chip layer, we moved into systems. We're going to go to the cloud now, and we're going to just keep tying all this together.
I love it. It almost sounds like this was very well planned out, Daniel. Great job. Do I give you credit or somebody else?
I cannot take credit for this, Pat, but I do think everybody out there is probably going to learn a lot here.
Yep. So stay tuned for Hillery Hunter. We're going to be talking IBM Cloud. Hillery, how are you doing? Thanks for coming on to the 6-5, first-time guest. Great to see you.
Great to see you as well. Really a pleasure to be here.
Yeah, we're having some great conversations here in Yorktown talking about the future of computing and the role that IBM is having in it. And we're here to talk about IBM Cloud's role in that. So thank you so much for coming.
Thanks so much. There's such exciting stuff in Yorktown, and we have such great partnerships there. Lots of technology that comes into our cloud comes out of IBM Yorktown.
Yeah, it was really enjoyable to come on campus, got the tour. We stood at the Watson Jeopardy. I took a picture standing behind the Watson computer because I wanted everyone to think I'm the Watson machine that won the game. Turns out I'm not, Hillary, but that's okay. So let's talk public cloud. Let's talk about IBM Cloud. It's a part of the business that sometimes I think we could talk about more, that I think that there's a big opportunity for the company. I'd love for you to sort of start out sharing a little bit about the IBM Cloud, its differentiation, how you've sort of focused on some specific verticals, and sort of what's working right now, and kind of what should the market know about IBM Cloud?
Yeah, I think it's interesting to think about what has happened with cloud over time. Cloud is definitely a place, and it's a set of technologies. And for IBM, it's also a hybrid cloud conversation. And so the specific positioning of our public cloud has evolved a bit over time. And I think where we're at right now is very much in alignment with that overall IBM mission as an enterprise IT provider. It is also very well aligned with our hybrid cloud story, which may be a little bit, surprising to say from the public cloud lens. But what I mean by that is our public cloud is positioned as focused on enterprise workloads, mid to back office, regulated workloads, and on contextualizing public cloud adoption for industries, for example, regulated industries like financial services, like telco, like healthcare, et cetera. Traditional clients who, really value what IBM does from a security perspective, what we do from a compliance perspective, et cetera. But we work with our clients to help them trust the public cloud as a deployment location, even for their most sensitive workloads, because of the data protection and other technologies that we have. But we also work with them in the context of IBM being a hybrid cloud company, where they're looking to have consistency between their on-premises estate and their cloud deployments, or they're looking to have consistency in a single control plane across their public cloud deployments on multiple providers. And so we deliver technologies that help secure their most sensitive workloads in our public cloud, and we deliver technologies that help them get consistency across their estate.
So Hillary, for what it's worth, from one industry analyst to you, I do like the strategy. It's a natural for me. When I look at where IBM has had a high degree of success the last 30 years, it is in these environments. And whether it's on-premises or cloud, it's very similar types of regulations, security, like you said. So it does make sense to me. Now, IBM Cloud does participate, though, in the overall architecture of a cloud as well with Red Hat, right?
Absolutely, yeah. And I was deeply involved in the Red Hat acquisition and in the overall hybrid cloud strategy that we established at the time. And for us in the public cloud, OpenShift, we run it as a managed service. We help distribute it, and other services in a common control plane out into other environments. And a lot of, these clients in IBM's core base within regulated industries, they need that optionality. Cloud concentration is a great concern. And so they want to be able to deploy their OpenShift-based workloads that they have on premises. They want to be able to deploy them in the public cloud so as to have more flexibility, more elasticity, be able to respond to things happening in the market. They want to be able to deploy it consistently across environments, et cetera. And so, the Red Hat alignment for us has been really great. It is a key part of how we help our clients envision the transforming of their estate into public cloud.
It's interesting, Hillary, you're talking about we're working from the public cloud backwards. Now we're going back on-prem. We've talked a little bit about the Red Hat, involvement. And here in Yorktown, we spent a lot of time in the research, looking at things that are being developed. And IBM does a lot of research and development. We saw the quantum machines today while we were here, but we also know that IBM has a big role in leadership in the semiconductor space. A lot of research, transistor research, things that are being done that will probably be seen as breakthrough on ultimately some leading edge part that'll get put into a phone or into a computer. But bottom line, IBM has a big part to play in that. But what about in terms of in the cloud? How do you see the IP, the research, development, and leadership that's done here in Yorktown and other IBM R&D facilities participating in the evolution of your IBM Cloud offering?
Yeah, it's truly soup to nuts. And we have had this luxury for the entire time we've been a cloud provider of being able to do that soup to nuts, type of approach, custom hardware, all those other kind of opportunities afforded by that skill base that you were describing. Maybe just to highlight just a couple of things, because I could talk about this for hours, but our cloud, in order to do data protection at the industry's highest possible standards, leverages technologies that are done jointly with IBM Research on cryptography, that get built into our LinuxONE systems at IBM. And it's custom hardware design all the way down to the transistors and all of the math, that then helps our clients know that their data is their data and only their data in the cloud. So whether or not it's on the cryptography side, on quantum secure cryptography, we have deployed the algorithms that have recently been selected by NIST to protect us against a future, quantum state. And we also bring IBM's quantum capabilities, both the developer environment and actual access to the machines. We bring those to market actually through the cloud. So whether or not it's the current problems and protection of data that are running on any type of servers in the cloud, but protecting the data, leveraging advanced cryptography techniques and hardware techniques, through to protecting the future and then developing the future and looking and exploring the future of IT, including quantum. We bring all of that to market and all of that to bear in our cloud.
That's excellent. So Hillary, thank you for bringing Z technology and LinuxONE to the cloud. I know you and I had a conversation a few years back on that. So, and it's great to see in areas that just make sense, like security. I love that. So Hillary, you talked about how some of the things going on in Yorktown are making its way into the service line today. But what about the future, right? We've seen some amazing quantum innovations here. In fact, we went through the lab that was here. We've talked about AI and things like AI in the edge and moving data around. What about the future? How are you looking at IBM Cloud and future innovations?
Yeah, to be honest, we're getting all those things that you were mentioning out to our customers through kind of the fluidity of cloud, the quick turnaround time, the ability to deliver stuff as a service, put things out in beta, help people try and experiment them. I don't think there's anything you mentioned that we're not actually doing, even today with our clients. Whether it's, the latest in AI stuff or quantum technologies or, experimentation with homomorphic encryption so people can, privately compute on things. But honestly, I'll say also up into the stack, serverless computing and changes in, orchestration models for workloads and how they're developed. We have a very tight partnership with research and with Red Hat on many of those different topics and technologies. And, in edge computing, with IBM Cloud Satellite, we can then, help our clients deploy those technologies where their data is as well, right? So whether the data is in IBM Cloud or, on their premises and retail branches they have or other things like that, we can help them quickly deploy those latest innovations and chatbots and virtual assistants and all that other kind of stuff. So I think we see a hybrid, and I guess hybrid forms of computing in the future. IT is taking on new types of computing with quantum and stuff. So both in sort of the hardware side as well as then in the software and the development, we're continuing to build out the latest models together with research.
As I read into it, Pat, really, she's telling a story of a very distributed compute future that requires a combination. It requires public and multi-cloud, which, by the way, aren't the same necessarily as hybrid cloud. And I think the market sometimes gets these things conflated a little bit. And that enterprises and organizations are going to have data and compute and workloads all over. And it's going to take a very thoughtful, well laid out, cohesive infrastructure to address that. And it sounds like that's what what you're really focused on, Hillery, with IBM Cloud. And I think in those specific industries and those vertical use cases, it's really been a winning formula. And it's going to be very interesting, at least from my analyst view, to watch how that sort of expands into other industries, other workloads, and other opportunities in the future. But I think it sounds, Pat, like they're really on the right trajectory.
I like where we're going. And Hillery, just want to thank you so much for coming on the 6.5, talking about, the more about what the company's doing from end-to-end computing, the future of computing, and how IBM Cloud fits into that picture. Thanks so much.
Thanks so much for having me.
That was a lot of fun, very interesting conversation with Hillery. The cloud, something you and I spend a ton of our time thinking about, discussing, and of course, where it's all going, multi, hybrid, and then where does it connect to there? Infrastructure, semiconductors. I mean, we really covered it all.
Yeah, we did, and I really did appreciate the clarity that it brought to IBM's strategy of it, right? They're not a cloud for every single workload out there. They're a cloud for, I think, the customers and for the applications that they've had decades of success with, right? Highly regulated, highly secure, and stuff that you just can't have mistakes on, or it's really, really bad for you as an enterprise.
Well, you look at things like security. It's a rising topic of importance at the boardroom, at the CEO level. Companies know that the vulnerabilities and the risks of security are massive, and the implications are massive. And as data continues to proliferate, these organizations need to be thinking, am I partnered with the right organization? Yeah. And that's where the whole cloud concept of, it's not just IaaS, and it's not just PaaS, and it's not just software as a service. It's really all those things. It's the big C, and it includes the consulting and the service, Pat, and the design. And I think that's kind of really the roots of IBM. And I love the fact that they're not saying we are for every workload. They're basically saying we have parts that we are confident we're the best. And then in some cases, it might be AWS, it might be Google, it might be Azure. These players are all there, and I think they understand their role.
Yeah, and I'll put an asterisk on it. When you do overlay Red Hat, I mean, Red Hat can be everywhere, right? For every workload, but that is not necessarily the tip of the spear for the IBM Cloud. And that's why in many ways, even though Red Hat powers the IBM Cloud is not Red Hat. So and that's why we appreciate the separation that they put in there.
Well, you and I have had plenty of time. We've had chances to sit down with Arvind. We know that hybrid cloud and AI data story is really at the core of what IBM believes. Red Hat was a big enabler. Their public cloud offering is significant, and it's in these specific enterprise workloads, these highly regulated, that makes sense, Pat. Another area that really is going to just continue to grow, continue to proliferate, and create opportunities for the cloud and for this full stack future of compute story is at the edge.
That's exactly right. And with that tee-up, thank you very much. We're going to talk to Nick Fuller, who runs research for the distributed cloud, talk about how AI basically permeates in everything outside of the data center. So super exciting. Stick with us here, folks. This is going to be great. Nick, it's great to see you. Thanks so much for coming on the 6.5. First time.
Thank you. Good to be here, Patrick.
Absolutely, yeah. I appreciate, and we're continuing this conversation talking about, first of all, holistically in the market, what clients are looking for in terms of the future of computing, where hybrid cloud comes into that. And hey, we're really lucky today because you run research for distributed cloud, AI, data, everything. So thank you so much.
It's great to be here with both of you. Thank you.
Yeah.
Thanks for having me.
You didn't use the E word, the edge, but yeah, Nick, reading your bio, first timer on the 6.5, super excited to have you here. You're covering a lot of ground, and I think as we sort of tell this future of compute story, you really can't tell that without talking a lot about what's going on in the distributed cloud and like I said, the E edge. Big story, big opportunity. I mean, we're all hearing the data numbers about the proliferation, exponential growth in volumes of data, and enterprises around the world and every other organization that uses compute are focused on the opportunity at the edge. So I'd love to get your sort of take on how IBM perceives the edge, the opportunities, the challenges, and sort of what you're working on in this particular space.
Absolutely, Daniel. So when you look at edge, there's a key vector that plays a role here, and that vector is the increased disaggregation and decentralization that's happening from an infrastructure point of view. The emergence of cloud sort of suggested, when you go back to 2006, customers would move their workloads from their data centers to cloud, and those cloud data centers would be in specific locations. As time went by, you had the emergence of more providers like Ridge, like Cloudflare. Compute got better, the advancement in AI with GPUs and so on, accelerators, and customers needed to solve problems at the edge in addition to moving their workloads to cloud. So that vector of disaggregation is a key one from an edge standpoint. Additionally, for us, when you think through edge, because of that strong rise in hyperscalers, there's this notion of edge in versus cloud out. What does that really mean? Cloud out simply means you take your cloud stack architecture and you run that stack on a customer's edge, whether that be a retail appliance, whether that be in a manufacturing floor, a warehouse, what have you. Whereas edge in sort of lends itself to being cloud agnostic, but also really critically elevating the data plane to a first-class citizen. From a cloud out point of view, the control plane dominates and data is not really first class. We see that as a key differentiation for us as a company.
So the industry has had a lot of changes over the last 30 years, and one of the biggest ones, interestingly enough, even though it's maybe 25% of the data moved from the on-prem data center to the public cloud. And there were a ton of lessons learned there, right? It's been 10 years, maybe it's glass half full where you would have expected more to be there if it were so easy. But there are some things keeping that from happening. But IT has learned a lot. What are some of the lessons going from on-prem data center, Colo data center to the edge that you're seeing? Good lessons of how to do it and maybe some things to stay away from.
Yeah, fantastic question. So, and when you go back to that original trend that you highlight, data privacy, obviously compliance and regulatory issues as it relates to different geographies, obviously all played a role. And then the value prop that many companies thought they would be gaining by moving their workloads to cloud, namely to enhance developer opportunities, to grow new business, and certainly to reduce technical debt, some of those didn't actually pan out. But really what still matters at the end of the day to an enterprise, to a CISO, to a CIO, to a CTO, the same factors rear their beautiful head. Security, software delivery lifecycle, and overall manageability of that portfolio. These things continue to be relevant from an edge standpoint. And we see that to be true as we look at the various enterprise clients with whom we work as it relates to the innovation we're building for edge computing.
Interesting.
So IBM has clearly put kind of an all-in approach on a platform that has, basically common platform for your distributed infrastructure. That was a mouthful, but I got it. How does this provide an advantage? Because this is one of the things I think a lot about, and I do have an answer for it, but I'm gonna let Nick answer this. Talk about why you've gone down that route, the advantage it creates, and kind of the challenges as companies are trying to move in this direction if they don't use that common platform.
Yeah, fantastic. So The platform weighs into what architecture you ultimately are adopting from an enterprise standpoint as you go on that journey. At the heart of this all, you're trying to solve some sort of challenge that grows your business, right? Whether that be from a savings standpoint, from a revenue standpoint, that's really what an enterprise is aiming to address. Our platform, based on OpenShift and various extensions of that as it relates to footprint and location, so single node OpenShift, microshift, et cetera, running on a range of infrastructure, gives customers that flexibility as it relates to running their workloads on the edge to solve problems in quality control, for example, retail ordering. You might have seen IBM's recent acquisition in the quick service restaurant space with McDonald's. All of these are critical. These types of workloads, whether it be in the case of quick service restaurants as far as natural language processing for order taking, whether it be for visual inspection, for quality control in manufacturing, or a range of other applications, when anchored on that platform, right, the various versions of Red Hat's platform that I mentioned, microshift, single node OpenShift, and full-blown OpenShift, gives you an architecture with data and AI capabilities that we're building for what? Scalability. That ultimately becomes the challenge that you face moving from a proof of concept to getting into full-blown production.
So we talked a little bit of the green room about, hey, this edge thing is new. Well, okay, well, we've had compute on the edge for a long time. What changed? And I think we can agree that, first of all, there's a whole lot more data being electronically captured on the edge versus maybe paper tallying, doing cycle counts. It's automatic when somebody takes a loaf of bread off the shelf at a grocery store. We finally have enough compute power, and we have machine learning algorithms to run against it that are very efficient. But listen, we've talked a lot about the infrastructure, but I think I'd really love to hear about the data. And I want to hear about how IBM is leveraging AI, machine learning, and even, let's say, a distributed data fabric to make all of this easier and more effective.
Fantastic question. So, and I touched on this briefly a second ago leading into this question. When you solve a problem initially and you demonstrate feasibility, it gives you an idea of how practical that can be as far as addressing that issue, usually with AI machine learning, whether that be NLP, whether that be computer vision, what have you. When it comes to going from that proof of concept to running that model in multiple places, running many more models scaled by orders of magnitude in a variety of locations, that cannot be done with the same type of infrastructure. The anchoring platform helps, but you need an architecture that's scalable. And the scalability in that architecture, you're able to leverage that first vector we touched on, the disaggregation and infrastructure. And that choice is up to the client, right? Whomever you've chosen as your hyperscaler provider, that's your choice. That's where you'll do your model training. That model will then be served at a particular location, right? A retail branch, a warehouse, a manufacturing plant, et cetera, for some type of issue to address. And let's take the visual inspection one with manufacturing. You solve that issue, but then as you build more models, are you really going to take the point you made with all the data being generated at those locations back to the cloud? It's not practical. You need an architecture that allows you to take some of that back to the cloud. And what we do here is build a range of data and AI capabilities that are platform-centric. So, for example, imagine you've generated a ton of data from various locations, and now you need to retrain the model because there's no supervision there, right? When you pull up, maybe you still do, and I don't, maybe none of us do anymore for that matter, and you order something at McDonald's and you say, I want a large fry, and they got it wrong. Well, there's a way for the model to be supervised there. But if there's a shift on the manufacturing floor, no one's supervising that. You need a way to ultimately determine if that model has drifted. You need a way to determine if you can take that set of data that has been generated and only take a sample of it, because the images are fairly similar. So we use AI and machine learning to cluster data, so we figure out what goes back to the cloud, what stays on the manufacturing floor. We infer whether the model has drifted or not using a variety of techniques. And that helps with not only the onboarding of new models, but the ability to scale that infrastructure from plant to plant to plant.
Yeah, Nick, no question there's a ton of opportunities and challenges being presented, and federating certainly can help solve some of them. You know, I think about, the examples that you give, and we certainly have the opportunity now with all the data at our disposal to keep getting better, to keep getting sharper, and to improve all the different types of edges, the retail, the bread on the shelf, right? The next generation of shopping, certainly, and of course, factories of the future, the edge, the opportunity there, significant. But the challenges, because of distributed architecture, they're palpable, they're significant, and
Absolutely.
something that we expect and we'll be watching as analysts for you and your team to continue to evolve and innovate upon. And Nick, we'll look forward to having you back to talk more about all the things you're doing at the edge, distributed cloud, and more as part of our future of computing story.
Awesome.
Thanks,
you, Daniel.
Nick.
Thank
Appreciate
you,
it.
Patrick. Appreciate it. Pleasure.
So I really like that conversation with Nick. I mean, not only did it show the power of the edge, but also some things to think about in practical terms if you're looking at moving a lot of your applications and moving a lot of data around. Data's going everywhere. There are some things that enterprises really have to think about.
Yeah, we've spent the last few years doing a lot of research, spending a lot of time discussing the edge and what this looks like, the rapid proliferation of data, the exponential volumes of data that companies, enterprises, and organizations can benefit from. And it also creates immense challenges. The more you move around, the more quote unquote edges you create. That really requires more thoughtfulness in how you build out your architecture, create that common platform that we talked to Nick about, because that edge is only going to get bigger. Well, the data centers, at some point, there's only so much physical footprint. And by the way, that maybe they even get smaller. The edges are going to be more prevalent, more voluminous, and that's going to create a lot of challenges.
Yeah, I get the question a lot, Daniel, which is, what changed? I mean, we've had compute on the edge for 40 years, and the way that I like to explain it is that you have more machine data now, right? You have sensors that are 50 cents that are, and you have cameras that are taking pictures of things going on, and not even necessarily for security, but things like inspection on an assembly line, right? Is this part good? And that a massive amount of data that's being computed can't all be shipped up to the data center or the cloud to be worked on. It has to be done in a much more intelligent fashion, like you said.
Yeah, there are some organizations that probably wouldn't mind if all that data went up to the cloud,
Exactly.
but that's not sensible. And going back to sort of the example you used with Nick about the loaf of bread, I mean, that's really, it's not a sensor necessarily on the loaf of bread, right? It's computer vision, and it's that computer vision taking snaps in real time over and over of a retail environment and everything that's happening. And you need that algorithm to be able to process to say, hey, that loaf of bread went off the shelf. What does that mean for restocking? What does that mean for revenue turnover? What does that mean for our margins? What does that mean? And so this is both the opportunity and the challenge of the edge, but I love it because basically, it's what also brings our world to life. It'll be the creator of the metaverse. It'll be the creator of the next generation of customer experiences. And of course, it will be an opportunity for so many enterprises to do more and be more successful.
Yeah, so I feel like key message here is, listen, you have an architecture for your on-prem data center. You have your architecture for cloud. You need an architecture for the distributed edge, and an architecture that ties all this together from a data perspective. So I think it's a good way to end this here. Great topic, but hey, I am super excited because next up we have Jay Gambetta, Director of Research of Quantum Computing for IBM, and he's going to close out our chapter on the future computing and things that IBM is doing to lean in and lead and help its customers.
Yeah, it's been great to see this sort of full stack story start from the inner workings of research and the semiconductors, move all the way through the cloud, the data center, the prem. We just got through the edge, and now we're going to look at really the next wave of Accelerator, which Jay will help us do, and it's going to be a great way to wrap up our future of computing.
Let's dive right in. Jay, it's great to see you again, and thank you so much for kicking off the quantum computing track at this year's 6.5 Summit.
Great.
Got a lot of people watching. It's really exciting. But we're here to talk quantum computing, but in the context of the big picture. We've been talking to a lot of your fellow compatriots about the future of computing, IBM's full-scale approach, but it's time to talk quantum. You're the last in this series of the future of computing, and let's knock it out of the park here.
Sounds great.
Yeah, Jay was a great guest at the summit, and so hopefully we can tie this together a little bit. It is a really big story, this whole full stack approach, and quantum is probably the one that people know the least about. And so I love maybe starting with that big macro view, Jay, of how IBM sees quantum sort of fitting into its full future of compute and full stack view.
Yeah, I think I would take it one step. I think the future of computing is not going to be computing without quantum. So if you think what quantum does, is it does some math that is really, really hard for classical conventional computers to do. So if we're going to build a future of computing and it doesn't have quantum, you haven't got the future of computing. So it's fundamentally has to be part of it.
We can just do a mic drop now, right?
Exactly.
Interview's done.
All right.
Well, I actually like something you said off camera though, because you said something about, sort of quantum computing and maybe, using some other vernaculars there, because you're sort of alluding to that already about sort of being part of the story and quantum accelerators and quantum, and I think that's kind of an important point to make early on in this conversation is that part of what's going to make it so important and such a big part of this future computing story is when people realize where it really fits in.
Yeah, I think you're exactly right. Like if you think of compute, it's everywhere. You check your weather, you're calling a compute. You do anything, it's compute. Computing is in our lives, it's everywhere. What quantum computing, and if I could get rid of the name computing as we discussed offline, what quantum really does is it adds something new to computing. And that something new is something we've never been able to use. And there's so many problems that we have trouble identifying, be it in business problems like optimization, chemistry problems, simulating new materials, even going into some of the ideas in finance and math. There's all these really, really hard problems, and we have new math. And when we can scale that math, that's where it opens up a lot more business.
Yeah, there's been I think generally people understand that it is the next generation of computing. I really do appreciate the notion of quantum acceleration, maybe a QPU or something like that. It makes total sense because when you look at the grand scheme of people understand accelerators and how to address them. So I like that a lot. I might take that and use it in the future.
Please do.
So the other thing, people generally agree that this is so big that amazing things in the future that we've never even thought of can be solved. But I also get the question, hey, what can we do right now? What kind of tasks and applications can we do right now?
Yeah, so we're in this really interesting time. So I would say we've been doing a lot of lab experiments, and we put it on the cloud, and we got numbers that are really, really great of how many users doing it. But most of them are still studying the noise in the devices. If you want to get to do something of business value, we've got to move beyond that. And so what I'm most excited about is I agree that there's this thing called error correction. Everyone talks about it. We've got ideas of error mitigation, but we're charting a path where very soon we'll be able to run these things we call quantum circuits faster than a classical computer can do it. And so we get right at that tipping point of creating a tool that you cannot simulate with a classical computer. So we're doing that, we've charted that, and we've got technical roadmaps. But at the same time, when you create that tool, you've got to start talking to the clients. What problems map to that tool? Right. And so what we actually see with all the clients we work with is we're actually learning, they're learning, we're understanding their use cases, and we're trying to understand how we can take that use case and map it to this new math that we know will have that tool. So what they're doing right now is they're doing exploring, but they're exploring this new type of math that does things like it changes machine learning with different types of, we call them kernels, or it allows you to simulate quantum physics by emulating it with a quantum computer rather than just using a big HPC computer that comes to an end. But it's doing everything a different way with a different set of math. And so we're at that point, I think in the next year, where you're going to see this breaking out, and how you use this tool, I think is going to be the exciting thing over the next few years.
That is exciting, and we talked in the green room too, kind of the flag plant of you have to give them the tools that are useful to get business advantage out of, and we talked about 2023. Yeah. Gosh, I think you did 6 or 7 announcements. IBM, I think it was Kookaburra. That was the flag plant.
Yeah, so Kookaburra was 2025.
Oh, excuse me, I was getting ahead of myself.
Yes.
In 2023, you've set the table so an enterprise could actually take your system and create something themselves. So maybe in 2025 they might see some value. And I'm making this up on my own, adding 2 years. I can do this. I'm an industry analyst. I don't actually have to do this.
So yeah, to try and so the one thing that's important is we're thinking long term. So we're building, so our roadmap goes beyond, right? We have a Heron, which is a 123, and we have multiple of them. Then we have Crossbill, then Flamingo, then Kookaburra, as you said.
Yeah.
And so I imagine keep building these up until really, really big systems so we can do more and more with it. What's exciting about 2023 for me is if we can cross that point of being able to do something we couldn't do classically, and then how we map it to clients, and that's going to start. I agree with you, it's going to take a couple of years to turn something into real business value, but it's going to, my hope is in 2023, it's not physicists talking about the noise in these systems, it's us trying to understand how business problems can run on them, and the noise is all handled in the software. So I agree in our roadmap, we talked about much more further in the hardware because we want to make bigger, but we also talked about simplifying it and making it easier for people to use. And so when we start to invent these things like when we make quantum serverless, Qiskit runtime, these things that start to abstract away the noise so physicists are not characterizing it, and you can start to actually use it by sending, like when you use a classical computer, you don't worry about the voltages. You call a library, and that library does the math that classical computers or GPUs are really good at. So it's an important inflection point, because that's going to be a point where I think we can talk much differently. And it's not about what's your error, like how many papers do you see, or how many people talk about error mitigation, error correction. Hopefully all that gets buried and it becomes how are you using it.
Daniel, you might like that.
Well, I'm pretty sure that the first year of quantum briefings I took were almost entirely about error mitigation, gates, and you know, how do you keep a qubit, you know.
Yeah, and I think most of the people in the room when I was doing it, it was like PhD, PhD, PhD. Yeah. They got to me not PhD. Yeah, but no, I'm super excited. 2023 to me is the flag plant where, not that it all starts, but this notion of enterprises having the tool, not focusing on error correction, but maybe working on a security application.
Yep.
Maybe working on something like that.
So classical computing, and just computing, because we don't normally call it that except when we talk about quantum, tends to be built with a vibrant ecosystem. You've got startups, you've got big players, you've got a lot of collaboration. Quantum's kind of interesting. So, you know, you've got this full stack story that IBM's trying to tell. You've got this full stack sort of quantum approach that you and your team are working on building. How do you balance sort of trying to take the whole problem on, from, you know, the hardware, the software, and all the other abstractions that you mentioned, and at the same time create sort of that vibrant ecosystem and be inviting? Because that's what's going to make this really practical, is when the right applications mapped to the right customers become readily available to be run on quantum circuits.
So I agree. I think the first part is yes, I call it classical computing, quantum computing. We've got to start calling it computing.
Yeah.
And when we get that quantum in it, I actually think when we say full stack, like we're talking pretty low in the stack. If you're gonna, you can totally imagine a startup creating a library or a software application that calls computing. So I envision us creating something very similar to like accelerators, NVIDIA, and things like that. There is software, it's not just hardware, that gets that accelerator to work. We have to create that software because we know our hardware best that gets that to work. But if we're going to create this industry you're talking about, that software's got to connect to their software. It's got to connect to data. It's got to connect to other clouds. And all of that has to work together. So we see ourselves creating, yes, some verticals all the way up, but really focusing on a compute layer that includes software and hardware interacting very much together. And I think this is what's different about accelerators to CPUs. Like traditionally CPUs is you build your hardware and then someone builds the operating system. When you have an accelerator like a GPU, there is software there. Quantum's going to be the same. You got to have that software that gets the most out of that accelerator, and that is how you build this full stack.
I love that analogy, by the way. The GPU is such a better analogy than the CPU for
It
quantum.
is, and by the way, before that, I mean, there are hundreds of ASICs,
Yeah, absolutely.
through history that have done the same thing. They just didn't get enough of that play. But I think for understanding purposes, I love it. This is an awesome accelerator to do some cool stuff.
Yeah.
So I've been interacting with IBM probably since the mid-90s. IBM Semiconductor, and you've developed a lot of IP around semiconductors, but also around high-performance computing. I was struck at IBM Think with many of your announcements. I'm thinking, I think I've seen this before. I think I've seen something that's similar to that. And then big company like IBM, I'm wondering, gosh, big company really changing the game versus maybe a smaller company. And I'm wondering, is this an advantage for IBM versus maybe a startup that doesn't have a whole lot of IP in semiconductors and HPC?
The short answer is yes.
I think I
Leading the witness.
I
right?
think I led the witness on that one. So,
But if you look at the details that go, the reason we've accelerated so much on the packaging and the things that go is we can leverage everything that we've done in semiconductors in the past. We're taking semiconductor physics, superconducting materials and physics, microwave technology, and we're merging them. And so that semiconductor history, we're using it all the time, be it from bump bonds to through substrate vias to all the things that make traditional computing work really well. We're leveraging it and putting it in-house. And I think this is what gives us an advantage and is why I am confident, and we're working so hard to win that sort of accelerator space. But I do think there will be startups that will come up with key IP in the stack that work with us, or calling those accelerators. But to compete in the accelerator, it's going to be hard to compete with the rich history of all the semiconductor knowledge and all the infrastructure that is needed to build these.
well, and for years, IBM was king of the hill in HPC. How does HPC relate to this? I don't want to put words in your mouth again, but I kind of look at the scaling and things like that. How does that help?
I think it comes back to what is the future of computing? I'm putting this word out and starting to see if it sticks, of quantum-centric supercomputing. And the idea there is we're going to think of our accelerators, but then we want our accelerators to work with HPC or some more advanced general purpose classical computing to be able to do more. So how do we actually start to make workflows that call a HPC and call a quantum accelerator, and how do we integrate that tightly? Can we learn from where classical has gone with serverless and on these other technologies to do it? So I think the story of future of computing is quantum, HPC, AI, all of these things converging.
Yeah, there's a really strong symbiotic relationship between what you want us to now say classical computing and quantum. Full stop there. And I think it's important for people to understand that. And so you've done a nice job here sort of doing some of the mapping, talking about how the R&D and historic intellectual property development of IBM, which by the way, I think often doesn't get enough credit.
I think not that patent counting is the ultimate way to view it, but IBM's been top in the number of patents for, 30 years?
That's
A lot of innovation though in transistor technologies and IP for semiconductors. But I'm also a guy that likes to talk to markets. I like to talk about practical business value. And you kind of started going down that path. But let's fast forward a couple years ahead. So we talked about 2025, 26. What are some of the things that you're advising to the ecosystem of customers that are going to be adopting this? Financial services, healthcare, chemistry, and of course academia, but all the places that want to really put quantum to use. Kind of what does that next few years look like as they prepare themselves for a quantum future?
Yeah, it's one of the things that we've tried to do differently in our IBM Quantum team, is how do you create an offering where you can work with the clients that is not research based. Like traditionally, if it's this type of technology, a lot of them start like, let's get together and research on algorithms. That we still do and is needed, But what's more important to a lot of clients, they're asking, how does quantum fit into my future? How will we be able to, what use cases will map to it? How will I be able to explain to my customers quantum? How will I be able to explain to my external stakeholders quantum? And so we tried to develop a way. So we actually brought people from IBM Consulting, and we made a small team inside IBM Quantum, which we mixed with a few researchers, and they're exactly doing this with a lot of clients. And why it's so important is you've got to answer all those questions. How's quantum going to matter for my business model? How's quantum going to matter, for my business? How am I going to communicate that I'm using quantum to my clients? On how am I going to get internal stakeholder understanding the value of this? And this is it's all a discussion, a relationship coming backwards and forwards. And at the same time, we are learning what use cases matter for these industries. And then our researchers, which are researching these algorithms, they get a bit of guidance of what type of algorithms should we actually be determining the quantum circuits for, because we can start to connect those dots. So right now it's about connecting dots, as we said, like our goal is 2023 to have something that's useful and keep scaling beyond. But it takes a while to connect dots, and I agree with you, 25, 26 of when it really starts to matter to business, but it's connecting dots and understanding what is the long-term return. And so I think of the future of quantum computing is going to support various different businesses. We've talked about the compute one. It's going to be like an accelerator as well. There will be companies that will have expertise in chemistry. Will they be able to use this compute to come up with a new catalyst and then be able to use that, like compute once, but then use that catalyst in many different places? They really got to get the expertise of how to use that compute. And so are the chemistry companies getting involved to work out the compute? But eventually they will want to be a solution, provide some type of solution or create something. And this goes all the way across finance. They may want to consume the compute to redo calculations, or they may want to do some logistics optimization, and then so they may want to create solutions. So I think we're going to see all this emerge, but right now it's about how do I understand the value of quantum and how can I map it to all my stakeholders.
That was one of the most understandable, like, what do I do next? So first of all, thank you for that. Maybe it's just because I have to hear it 2 or 3 times to fully understand it. That's a possibility, but I think it's a lot of your ability to put it into simpler words. And I think as part of what we need in quantum is maybe a simpler vernacular. And I think naturally we'll get there. Again, 25, 26, right? I think I'm super excited about, but Jay, I really appreciate the time. Once again, an incredible discussion about quantum. I learned a lot, which I guess that's a good thing, right? Or good thing or bad thing if I didn't study the notes up front well enough. But I just want to thank you very much and for closing out our discussion of the future of computing and what IBM's doing about it.
Thank you very much. Thanks.
It's great talking to Jay. I mean, my biggest takeaway was when things are going to happen. And I know it was on the slides, I know I got the briefings, but 2023 is when the technology is going to be there for enterprises, not physicists, to start to create something to provide business value so we can extrapolate that out to 25 or 26. That was my biggest takeaway.
Yeah, that really resonated with me as we were sort of looking for that answer. I like to find a way to always create a thread between the technology and the business value. Otherwise, it's pretty nascent. It's a science experiment. It's for academia. But we know, as we saw the rise of AI, of HPC, of accelerators, we know that the goal, especially with a lot of things with complex math, is to be able to go faster. And quantum is sort of the next, quantum leap. In terms of being able to make workloads go faster and solve some really complex problems that historically classical computing have not been able to solve or solve very quickly. And so that's really exciting. And also, Pat thought it was a really nice way to sort of sum up the whole future of computing discussions that we had here at IBM.
Sure, and it's interesting. I do like the notion of a QPU, right? This is an accelerator, right? It's not going to run on an operating system. Sure, you're going to have APIs and low-level things like that. But this is an accelerator, similar to a GPU, which then, when you come out and you dial out, it's just another version of it. It's the biggest quantum leap in computing, but it's heterogeneous computing, which I think we can all relate to with GPUs as accelerators. And then if I take it a step further to how accelerators help the cloud, and the cloud model, the quantum cloud model that IBM is creating, where if you have an API and you can use it even if you're not booting up an IBM server or something like that, but you can get access to the IBM Quantum Accelerator and put it into your application. Maybe even an application that you've had for 10 years that you just want to accelerate and make better.
Yeah, the future of computing is tying all these components together, right? It starts with the R&D, it starts with the stuff happening in the labs, building out the next technology, innovation, thinking 5 years and 10 years out. And then it's a lot of the stuff you and I talk about every day. It's the more practical stuff. It's the data centers full of compute and GPUs, and then applications and data and companies, businesses being able to do something meaningful with it. And so what I really liked with this last conversation was basically how it just tied together everything else. It's really, a future is all about getting more from our data. It's getting more from our systems. It's being able to solve the bigger, more complex business problems. And so hopefully everybody that joined us for these sessions really kind of got that. They kind of saw how all these threads start to tie together to create real, meaningful enterprise value through the utilization of a full stack approach.
That's right. Hybrid cloud, the edge, AI, semiconductor, IP, and technologies, and here we are with quantum. Great place to end. This is a great, fun day. I love compute, and I know you do too.
Absolutely. So thanks everybody for tuning in. We really appreciate you joining the 6.5 on the road here at IBM.